about the Pythagorean theorem to find missing sides of right triangles. Today we're going to kind of look at a shortcut for finding missing parts of special right triangles. So one of those special right triangles is a 45, 45, 90.
And then 36
Meaning, if we have a 90-degree angle, one of the angles is 45 and the other one is 45. Okay, we have a 45, 45, 90 right triangle. Well, if these two angles are the same, if these two angles are the same, then what do we know about these two sides? They're also the same. We don't really know what value they are, but we're just going to label them with X and X. Okay? To get the hypotenuse in a 45, 45, 90 right triangle, you multiply one of the legs by radical 2. So literally all you're doing, and when we say multiply, you just take the leg and you literally just write radical 2 next to it, and that's the hypotenuse. You don't need to plug in your calculator or do anything. You just take the value of whatever the leg is and write radical 2 next to it. So your options in a 45, 45, 90 right triangle, you're either going to multiply or divide by radical 2. If you need to make a note, this means multiply, not x. Do that to get your answer. You're going to multiply by radical 2 when you're going from big to small. Sorry, small to big. You got that flip-flop. Small to big. Meaning when you're going from a leg to the hypotenuse, you're going to multiply by radical 2. When you're going from a small part to a big part, multiplying makes it bigger. You're going to multiply by radical 2. If you're going from the hypotenuse to a leg, so if you're going from big to small, big thing to a small thing, you're going to divide, because dividing makes it smaller. So again, when you're going from the hypotenuse to the leg, you'll divide by radical 2. So leg to hypotenuse, multiply by radical 2. Hypotenuse to leg, you're going to divide by radical 2. Every time. Depending on what piece you're given and what piece you're trying to find. These two are easy because they're always the same. So this is 7. That's going to be 7. Those are always the same. Questions over there. It'll make a little more sense when you actually see a problem. Right? The other special right triangle is what we call a 30, 60, 90 right triangle, meaning one angle is 90, the little angle is 30, and the bigger angle would be 60. Okay? The length of the hypotenuse is 2 times the length of the shorter leg. And we know it's the shorter leg because it's across from the 30. 30 is the smallest angle, so that side is going to be the shortest side. That's the main side. We always want to find that side first if we're not given it. Okay? Once we have that side, the other two pieces are easy. Okay? The length of the longer leg, which is opposite of the 60, is radical 3 times the length of the shorter leg. So when you have your short leg, to get the hypotenuse, you want to cross from the 90, you just have to multiply whatever that value is by 2. So if this is 7, the hypotenuse is going to be what? 14. Okay. Take it, double it, that's the hypotenuse. To get the value of the side across from the 60, all you have to do is take whatever that short side is, right, radical 3 next to it. That's it. Questions over there? more examples of this. You don't have to worry about memorizing these triangles. You don't have to worry about memorizing this diagram. You don't have to worry about memorizing this diagram. You're going to be given them. So you just have to be able to look at the diagram and recognize, well, do I need to multiply or do I need to divide? And what am I multiplying or dividing by? So here, again, you're either going to multiply or divide by 2 when you're dealing with the hypotenuse. 2 is always associated with the hypotenuse in the 30, 60, 90. And you're either going to multiply or divide by radical 3 if you're dealing with the long leg. Remember, small to big, you multiply, big to small, you divide.
What's the shortcut?
There's a way to help memorize it. One of the biggest things that students tend to mess up is they both have a radical. The other one has a radical, the other one has this. I think this is what Kanaji was kind of saying.
1 train, 2 train, 3 train times 2.
Okay, however you want to think about it, yeah. I think of the 30, 60, 90, or you think it's when you memorize, you have 1x, 2x, x radical 3. Also, the radical 3, the number one thing students mess up is they have the radical 3 on this side. No, that is not the case. This is a radical 2. Think of the two sides the same, 2 over there. 30, 60, 90, it has a 30-degree angle, which has a 3 in it, so the radical 3 goes with the 30. This is one way of thinking about it. Let's try this out. Again, when we're always doing this, we have to identify what type of triangle we're working with, and then we're going to figure out what piece I was given. Either, in this case, the short leg, long leg, or hypotenuse. This is what type of triangle? Is this a 30, 60, 90, or a 45, 45, 90?
It says that on the top.
It does. So it is a
45.
There we go. So I know that this is a 45. Now the question is, in a 45, 45, 90, there's only 2 pieces you have. I either have a leg or I have a hypotenuse. What piece was I given? What value do I have? One of the legs. Well, the nice thing is this is an isosceles triangle, a right isosceles triangle. So if this side's 45, the opposite side's 9. Well, this side's 45, what's that side? 9. They will be the same, they're isosceles. That's good. It doesn't ask for it, but it's just nice to know that. But it does ask for H. So this is what you have to know. I'm going from a small piece, one of the legs, to the hypotenuse. What operation lets me go from small to large? Multiply or divide? Multiply. So I'm going to multiply. What do I multiply by in 45, 45, 90s? So only one option. Multiply by? Not 2. Radical 2. Again, everyone get out your calculators, get ready to go. I would take 9 times radical 2. Here you go. Here's what you do. 9. Put a radical 2 behind it. You're done. No need for a calculator. That's it. Make you guys out. See what I did there? You don't have to go. This is the exact answer. You could get an answer, and it would be a decimal. But then you have to round that decimal because it go on forever. So this is the exact answer. 9 radical 2. You just take the leg, tag on that radical 2 behind it, you're done. No need to go any further than that. Questions on that if you have a leg? Alright. Another one. We know it's going to be a 45, 45, 90. What piece was I given? A leg or a hypotenuse? Still a leg. Well, if I know this is 2 radical 2, well, this side's going to be 2 radical 2.
Wait. Wouldn't that be the hypotenuse?
Hypotenuse is always across from the right angle. So you draw a little line, there's the hypotenuse. Good question. Now, how do I go from a small piece, how do I go from a leg to a hypotenuse? What operation do I do? You're going from a small piece to a large piece, operation. Multiply. What do I multiply by in a 45, 45, 90? Well, one option. I multiply by radical 2. So I'm going to take this side, and I'm going to tag that radical 2 on the back of it. So I'm going to do 2 radical 2 times radical 2. I can simplify that a little bit, because I have radicals. Radicals are the same thing, so I can multiply those things together. When I do radical 2 times radical 2, what does that give me? Okay, what is it? Radical 4. So the 2 stays the same outside, it'd be radical 4. Not only is this thing called a radical, it's also called a square root. What is the square root of 4? 2. So really, this is 2 times 2. And 2 times 2 is? What's 2 times 2? 4. So this side is 4. It's on that side. Now, that looks like it's not a lot of work, but you don't want to do that every single time. Is there a shortcut with this? Yes, there is. Whenever I'm multiplying radicals, when they are the same radical, it's really a perfect square. It's always the same number times the same number. So all I have to do is look at one of them and get rid of the radical. Because I know it's going to be radical 4, this is reduced down to another number. So I know if there's a radical 2 there, multiplied by a radical 2, it's just going to turn into 2. So it would be 2 times 2 would equal 4. It's a shortcut. Don't believe me? Watch this one. If I said radical 15 times radical 15, you guys know what the answer will be without doing any of the work? Katie again? You know what the answer is going to be without doing any of the work? Well, we either could do that, or if I know that I'm multiplying the same exact radical times itself, it's just going to be whatever's inside that radical. It just cancels away.
So it won't be 30?
It would not be 30 because that would be adding together. It'd be 225. The square of 225 is 15. So there's your answer.
Oh.
Anytime you have the same radicals multiplying by each other, it's just whatever in that radical one time. Multiply that by that coefficient out there. Just an example. You'll see another example here in a second. This guy. Still dealing, flip it over, still dealing with the 45, 45, 90. Okay, you ask yourself, am I given the hypotenuse or leg? What do I have now? Hypotenuse or the leg? The hypotenuse is the correct answer. I no longer have the leg, I'm looking for the leg. So I'm given the big piece. How do I go from a big piece to a small piece? What operation goes from big to small? Divide. And what do you always divide or multiply by in 45, 45, 90s? Radical 2. Watch what happens here. So I'm going to do 4 radical 2 divided by radical 2. No need for a calculator here. What's going to happen in this problem? What happens with those radical 2's? They cancel each other out. So you are left with just 4. This guy's also 4 too, which makes sense. Because if I have a leg of 4, to go from a leg to the hypotenuse, I multiply by radical 2. So it would be 4 radical 2. Yes, good night.
So if we just put like 4, could we make them 4 when we get...
That's what it is, yeah. That's what these are. These are basically a shortcut to the Pythagorean theorem. So if you have 2 sides, you have to figure out the other one, you don't want to do all that work. If you recognize that's a 45, 45, 90, then yes, you'll put that there.
But without the work, without the...
Now, some of them you won't need work, Kanaja, but there's some that you definitely will, like this next one here. But if you recognize it off the bat, just like we have a P-trip, you can do it that way as well. All right, question over there, divide by the radical 2. All right, so this next one here. Going on the next one. Still dealing with that 45, 45, 90. What piece was I given? Leg or hypotenuse? Hypotenuse. So that means I'm going from a big piece to a small piece. I divide. So divide by radical 2. Well, the problem is there's no radical 2 up top to cancel out. Another problem is you cannot, I repeat, you cannot have radicals in the denominator. You can't have them down there. So think about when we do our bare problems to solve multi-step equations. How do I get rid of something in the bottom of a fraction? What do I do? Basically, I'm dividing these things, so what undoes division? Multiplication. So I'm going to multiply by this radical 2. Not only do I have to do it in the bottom, I also have to do it in the top. So we do radical 2 and radical 2. A lot of students will say, oh, I know what to do. We just got done with our proportion unit. I know how to solve this. But you do not cross multiply. When I am multiplying ratios like this, fractions, ratios, whatever it is, you multiply straight across. It's when you have equal signs when you cross multiply. So I just multiply straight across. 6 times radical 2, well, they're 2 unlike things. It would be like 3 times x, it would be 3x. In this case, it would be 6 radical 2. What happens when I have a radical 2 times radical 2? What's it become? It will become 2. You're exactly right. But for the sake of this drill, I'm just going to say it there. It will be the square root of 4. We automatically know what the square root of 4 is. I'm going to zoom down here to get this here. Square root of 4 is 2. We can do the shortcut, you know off the bat. So I have a fraction here. What do I need to do to all fractions I do from the end of time? Simplify my fractions. Can this 2 go into that radical 2? Are they alike? They're not alike. Can the 2 go into 6? Yeah, I can. What is 6 divided by 2? 6 divided by 2 is 3. So this just becomes the answer to be 3 radical 2. So I know this answer is 3 radical 2. And this would be 3 radical 2 as well. Now, this one's a lot of steps, isn't it, Kaja? A lot of steps up there. You don't necessarily want to do that. Is there a shortcut to help you out with this? Yeah, there are shortcuts. And I'll show you what it is. Whenever you're dividing by radicals, it doesn't matter what the radical is. Here's the shortcut to it. This top number, I want you to divide by the number inside that radical. So what is 6 divided by 2? 3. And then you take that radical, whatever that radical is, and you tag it right behind it. You put it right behind it. So it would be 3 radical 2. Watch this example over here. I'm just making numbers up. I'm going to say 9 divided by radical 3. You don't want to do that whole process again. So I'm going to take this number, divided by the number inside the radical. What's 9 divided by 3? 3.
So 3 radical 3.
And then I tag that radical 3 behind it. It would be 3 radical 3. That always works when dividing radicals. So the top one divided by the bottom, and then tag that radical, whatever's in the bottom, right behind it. Always works. Great way to do a shortcut. Okay, questions on the 45, 45s, 90s? Multiply, divide by radical 2. We're going to kick it up a notch. Boom.
Now we're going to take a look at 30, 60, 90 right triangles. Which side, you always want to identify that first. What part will we given? Short side, long side, or hypotenuse? Short leg, long leg, or hypotenuse? Short leg. How do we know it's the short leg? We wrote short, but it's across from what angle? 30. So we know this is our short side. Okay, this is the side that we want. To get our hypotenuse, what do we have to multiply our short leg by? Because when we're multiplying, we're going from small to big. 2. So to get our hypotenuse, we just have to do 5 times 2, which is what? There you go. Got your hypotenuse. To find the long leg, what do we have to multiply our short side by? What goes around the 3? Radical 3. When we say we multiply by radical 3, we literally just have to say 5 radical 3. Done.
Yes, I was telling you that. 1 train, 2 train. Wait, 1 train, 2, 3, 3, 3 radical 3. 3 radical 3.
Too much of a tongue. If that works for you, go.
It does.
Too much of a tongue twister for me.
You get it though? Because like 1 and then 2 and then radical 3. Because it's 3 trees, 3 legs. Yeah. I forgot the 45 minutes.
Gotcha. Okay. Questions? If we look at these, again, identify which piece you were given. Were you given a short leg, long leg, or hypotenuse? Hypotenuse. How do we know it's a hypotenuse? On your side, Sandra? Was it across from? Good. It's across from the 90, so we know we have the hypotenuse. So we always want to find the short side first. We want to find that side first. If we're given the hypotenuse, which is big, and we're going to a small side, are we going to multiply or divide? We're going from big to small. We're going to multiply or divide? Divide. And what are we going to divide by if we're dealing with the hypotenuse? You can look back at your diagram. That might help. Back at your diagram, what letter is written in the hypotenuse? 2. So we're going to divide by 2. Well, 14 divided by 2 is what? 7. So that's your short side. Well, to get our long side, our long leg, what do we literally just have to write next to 7? Radical 3. Literally take your short side and you write radical 3 next to it to get your long side. You're multiplying it by radical 3. when you aren't given, think about if you're not given a short side, you're going to divide in your first step. So here, we were given our short side, so we multiply to get our other pieces. Here, we weren't given our short side, so we have to divide first, then we can multiply.
Short leg's the key. You're always trying to get there first. Sometimes you're given it, makes it nice, super easy. If not, you're going to have to divide to get it.
So here we have a 30, 60, 90. We know it's 30, 60, 90 because we have a 90, we have a 60. So that we know this other one automatically has to be 30. Which piece were we given? Short, long, or hypotenuse? Given long. So what are we going to have to do? Multiply or divide first. We have to divide to get our short side. Okay? What do we have to divide by? 2. Not 2. What goes around the 3? Radical 3.
Oh.
Because we're dealing with the long side, so we're dealing with radical 3. We have to divide. Use that little trick Mr. Carr was talking about to simplify this, because we can't have radical 3 in the denominator. Can 3 divide into 5? No. So you just leave it as 5 over 3. And then what radical do we tack on after the 5? Just take the radical that's in the bottom and write it in the 5.
So basically oh.
So that would be the short side. Now that we have our short side, we're going to multiply. Once you have your short side, you're multiplying to get your next piece. If you don't have your short side, you have to divide to get it. Yes.
Wouldn't you just multiply the 5 like down here? Because you can just multiply it.
Yeah, so what do we have to multiply our short side by to get our hypotenuse? So we're going to, this is tricky. You have to do 2 times that whole thing. Okay, 2 times that whole thing. Here's the thing, when you have a whole number, what's technically in the bottom? It's a fraction. It would be 2 over what? 2 over what? Right? When you multiply fractions, you're just multiplying across. So you multiply the tops together. 2 times 5 is what? 10. You can't multiply the 2 and the radical 3 because the 3 is trapped under there, so you literally just rewrite it. That's not going to change. And then 1 times 3 is just what? 3. So that is your hypotenuse. That's a little bit of a trickier one. But you always divide to get your short side. Once you have your short side, you're going to multiply.
That's hard.
Of course. We'll get more practice with this tomorrow.
This is probably the toughest example you see. All right, let's start applying these concepts to the real world applications now. So we have this. Any softball players in here? Softball players? Softball players? Hey, one person. I know there's other softball. There we go, softball players. So when Coach Thomas asks you this question, you're going to know the exact answer right now. So a high school softball diamond is a square. Think about turn square sideways. It's a diamond. The distance from base to base is 60 feet. Is that true? Okay, good. So the nearest foot, how far does a catcher throw the ball from home plate to second base? Do you know?
We don't know. You have to figure it out.
I don't know. Let's figure it out here. So here's what we do. Let's draw a little picture. So I'm going to try to draw a diamond the best I can.
I just did this with Shay. You're in homework.
Maybe. So here's a diamond, right? Well, if it's a softball diamond, what do softball diamonds have in the corners? They have bases, right? So when I draw a base, look what's created.
Oh my goodness, it's no. 90s. So we're done.
There are 90s. I agree. And I want to know, if I'm this person down here, there's a person on second base, how far
180, I'm done.
is that distance? It's 180 degrees, I agree. But we will actually figure out the distance. Now, not only do I have that measurement, but I know the distance is 60 feet to each base. So 60 feet, 60 feet, 60 feet.
and it would be a 36.
You could use Pythagorean theorem. That's a great option you could do.
You could.
But I could also save myself some time if I do the trick. You could go right ahead, Gary. This would be my A, that would be my B, that would be my C. You could do it that way. Or if you know the shortcut, it will save you a lot of time. Now, some of you guys don't see it yet, but we know, I think someone said it, each of these bases is how many degrees? Each corner. What's the definition of a square? Each corner is?
Equal 90.
They are equal to 90 degrees. If I throw a ball right down the middle, what does that make each of those angles now?
45.
They do become 45s. So I know this is a 45, this is a 45. Not only that, this side over here, and this side over here. When I bisected, I made two 45, 45, 90 triangles. I'm going to draw it over here, because sometimes some students have a hard time seeing it. So just draw a triangle over the right. And we'll label it, you can visualize it a little bit better. So there's my
You
half
need
of
the
it.
help on that thingy. You need the thingy.
There's that, 45. I know this is 60. I know this is 60. So, I'm looking for this measurement over here. I have a 45, 45, 90 triangle. Was I given the leg or hypotenuse? Which piece was I given? Was I given a leg or a hypotenuse? A leg. How do I go from a small piece to the large piece, the hypotenuse? What do I need to do? Multiply or divide? Go from small to large? Multiply. It's getting bigger. Multiply. What do I multiply by in a 45, 45, 90?
2.
Nope.
I'm guessing. Hold on.
What?
Radical 2.
Radical 2. So, when Coach Thomas asks you what the distance from home to first is, the technical answer, the exact answer, is 60 radical 2 feet. That's the exact distance. So, if you want to say exactly how far you throw, what's 60 radical 2? But, do you really talk like that? No, you don't say, you don't go to the doctor, how tall am I? Oh, I'm 1 radical 5. That's how tall I am. No, you measure in feet. So now, this is where everyone has a calculator to try this out. Type 60 radical 2 in your calculator. If you are using our borrowed calculators, which a good portion you are here, these are not the greatest. You have to work backwards. So you take 2, everything backwards. And then to 2, radical or inverse square, then multiply by 60. So it's harder.
So what?
So it says round to the nearest foot. So what'd you get, Rosalind, when you said that? 84.8. So we're going to round it to 85 feet. It is 85 feet to throw from first to second. So you guys are pretty close. But pretty close.
Well, she said, don't. That's what I was going to bring for
And that's approximately.
We're at number 2.
Okay, questions on that? Let's do another one here. An artisan makes pendants in the shape of equilateral triangles. The height of each pendant is 18 millimeters. What is the length of each side of the pendant to the nearest tenth of a millimeter? Okay. Well, looks like we're going to be drawing an equilateral triangle. When I do so, it'll look like this. So, what are some things I know about equilateral triangles? The sides are equal, correct. And the angles are correct. Now, they're equal angles. So what does each of these have to be if they're equal?
90.
No.
30, 60.
They are all 60. So this is 60. This is 60. This guy's 60 right here. Now, I'm saying the pendant is 18 millimeters tall. So this is 18 millimeters. I want to figure out how long each side is. Again, I just need to find one of them. So, why is this helpful? Well, it's because look what I created. Just like the last time when I threw that softball across the way, it bisected that angle. When I had this height right here, or altitude, it also bisects it. So it's no longer a 60-degree angle, it is now a, when I bisect 60-degree angle, what's it become? 30. So now look at my triangle I just made. I made a 30, 60, 90. For those of you who don't visualize that very well, draw one over here. There's my 90. There's my 60. Here's my 30. And I know this is 18 millimeters. So there's my triangle. I need to figure out this side, this X over here. Well, I always need to go to the short leg next. How do I go from this long leg to the short leg? I'm going to have to divide because I'm going from a big piece to a small piece. What do I divide by on the long leg? You got to look back at your notes if you don't have it. What do I divide by?
Just kidding. No.
What do I divide by? I guess everyone look back. I have three people looking back.
Radical 3.
It is going to be radical 3. Because I go from the long leg to the short leg, divide by radical 3. So I'm going to do 18 divided by radical 3. The problem is you cannot have a radical in the denominator. So we found that little trick that you have to do. I'll take this top number, divided by the number inside the radical. So what is 18 divided by 3? 6. And then whatever radical's in the bottom, you tag that right behind. So that side is 6 radical 3. That's great.
I got to do all that hard stuff.
No, I don't do the hard stuff. How do I go from the short leg to the hypotenuse? I'm going from a small piece to a large piece, so I have to multiply. What do I multiply by?
By 2, which is hard.
It's real hard. It's real hard, I agree. So I'm going to take 2 times 6 radical 3.
You got to do all that.
You're right, I got to do all that. I'm going to do 2 times 6, which gives me 12 radical 3. Now, but again, we don't talk about things being 12 radical 3. Doesn't make sense. It says it wants nearest tenth of a millimeter. So now I go back to my calculator, and I'm going to figure out what that millimeter is. So this is going to be approximately how many millimeters? So I would hit 3 radical, whatever it is, do 12 radical 3 in your calculator to figure it out. Again, I'm telling you, those of you who are just sitting here staring at us, it's not helping you. This is the calculator that you guys are borrowing from us. You have to know how to use it. I'm not going to tell you the day of the test how to do it. Katie. What's that? Good one? 20.78 rounds to the nearest one. So it'll be 20.
Wait, how do I use this? Look, it says rad.
Don't use rad. So you work backwards. Edge is 3. Then I'm going to have to do the radical side. Multiply it by 60. Well, that's not right.
Why 60?
Here's the clear. Oh, 160. I meant 12. Let's leave the last row. Okay, so 3 radical times 12. You get the calculator to do 12 times radical 3. You'll get it. And if you don't have a graphing calculator, I recommend getting one.
We got 2 more.
Okay, right now, get out your practice and work on that.
Oh, I see 2 questions.
We're good. Get out your practice. So those. The ones you'll see there. So get out your practice.
Okay.
Work on your practice.